I'm very happy that you came. So this is kind of the most important track.
Oh, okay.
So those who are on travel today may regret it in the future.
I just realized that Rob's going to be the only person here.
Then you will be the true elite.
Because Austin has whatever his thing is tonight.
Huh?
I think Austin has something going on tonight, doesn't he?
I don't know, but it would be not right think of him to miss this one.
So do we still use the USD
Yes.
cluster?
I do this preparatory slides each year, but if I try to use whatever was prepared previous years, it doesn't work. It needs to be fresh, alive. Otherwise, I forget myself and not being enthusiastic enough to.
Oh, thank you. I wasn't sure if I could. Now I'm pretty sure everyone's here, unless Russell decides to show up. And Melissa, as her usual, I'll leave. Lost him. Sorry. Took a spill. Hey, so I was actually ahead of schedule for the lecture today. She actually finished all the material 5 minutes early.
I don't understand why people can't log out like it's a simple click.
So how does that get fixed?
You gotta like restart the computer, which is both a flaw on Windows 10 and also.
I don't think we can manually do that. Please though.
I will let you on campus, but I take that money. Oh. Is this another software that we open up through the supercomputer?
Yeah.
So we can log on in the same fashion? As
Yes,
everything?
yes. And you will need your homework on poly oligomer of titanium dioxide.
Which,
The longest one.
okay.
Okay.
And if you, by some reason, didn't succeed in it, or if you missed this homework, just respectfully borrow it from your classmates. You know how to do it.
Just the
Is it
the
an
structure
oligomer?
itself, or like
Huh?
one with the molecular orbitals?
No, we do not need orbitals. We need just geometry.
Oh, just okay. That was okay.
Is an oligomer of that size good?
The 5.
Five, and then we'll be cutting the edges and making the periodic unit cell.
So, what are the advantages of using VASP?
Solids.
Okay.
Solids, explicit solvents, and also not as a big science, just as a matter of convenience. Through my career, I have accumulated or contributed to design of several tools for post-processing output of VASP, and it will be a big benefit to use them because they are homemade, but they are sharpened for specific tasks that I want to believe are competitive.
In Austin, in Japan, that's there. One of the requirements before you graduate is to create your own analytical instrument.
Are there like actually useful ones that come from that, or just BS?
Well, like a lot of times it's just making your own UV viz or something, or like
I got it.
yeah, or creating some sampler to do a certain thing. It teaches you how to build something that you probably won't find in the marketplace,
I got you.
but something that would help
Right, so it's not like making something out.
you. Yeah.
It's our favorite image of recursion. Well, I congratulate those who found it possible to come. Thank you. You will not regret it. So it is something. Huh?
Yes.
American Physical Society Research Conference. I hope they will be able to pick up after us. But if they not, they may drop the class immediately.
I don't think we have to worry about grading.
It is something substantially new.
Oh, okay.
So, in fact, class starts now.
Oh,
You can forget everything that was before, and it will not contribute too much to the final success. So we will do another presentations where you will share your skills, and I will work on it. Is from the last year, but it is basically same type of skills as you sharpened for Gaussian, but now it will be new software, so-called VASP, which is abbreviation for Vienna ab initio, something from Austria. So you do have this pieces of paper, and I have them also. And I can go over them. I scratched it once when I was training my first graduate student 7 years ago, and later I realized that although it is very ugly calligraphic, I cannot do better. it is a condensed summary of what has to be done. So I'm not sure if you need to spend time on this introductions. We'll better do practical things. But I'll briefly go over what is here. So in Gaussian software, you do have one input file, right? Which contains information about your atomic model, about configuration, about charge, multiplicity, basis set, potentials if it is exotic elements, like EC, and task what you want to compute. The new software that we are starting right now is less user-friendly. First, it doesn't have GUI, graphical user interface. So there will be no chance to mouse click. Everything will this software compared to Gaussian is like stick shift compared to automatic. So you will need to do a lot of things manually. The thing that kills many people and prevents them from using this nice software is that there are 4 input files. One for geometry, one for potentials, one for what we want to be computed, like spin, multiplicity, optimization, or molecular dynamics. And the fourth one relates with the Bloch theorem that you saw in class yesterday. The fact that there are solutions where electrons move through periodic boundary conditions. I'll talk about it later. And our life is a little easier because we will have the collection of templates. So if something is similar, instead of designing these 4 files, we will use samples. If you are bored listening to me, you may log into the cluster, so that and also make sure that you have a graphical connection through your favorite tool. For me, right now it is mobile external. So there are four files, and we cannot go forward before we learn how to convert standard information about atomic model coordinates into specific format for this software. So this is mostly painful procedure, and I'll probably go to. Okay, I'll chat a little bit so that you have a slow warm up. So the we will come through this scratch slides again and again, but in your up-to-date experience with Gaussian software, you had your molecule and the whole universe, a lot of vacuum or you don't care what around, right? From now on, this software that we are start to use, we will always have periodic replicas. If you have a molecule, next door it will be a copy of this molecule. Next door will be another copy of this molecule. Infinite number of copies to each side. And so you do not have infinite space around. You have a fixed space until the door, until the end of the box. And you need to specifically tell how much vacuum you have until the next periodic image. So it is one aspect. The size of the cube, size of the box will be always specified. Another thing, how do you measure coordinates? In which units?
Angstroms?
Angstroms, and you can convert maybe in nanometers, and you use the same units for each molecule. The units do not change. Prepare to suffer. In VASP software, units change each time you run new model. So the coordinates are recorded in the fractional coordinates units. So you have the size of the box, and it is whatever you specify the box at the top of the file, and then you measure positions of atoms, X, Y, and Z, in fractions of the box size. So the coordinate is never bigger than 1 and smaller than 0. So it is position of ion divided by size of the box for X, Y, and Z. So for computation it is a little easier because you know that these numbers are always between 0 and 1, but for human perception it is a pain. So we will use specific tools to transform force and back. But all this inconvenience is paid off later. So it is really, really powerful software for a lot of applications. So it gets much more functionality in describing real life. Okay, so two main ideas: add vacuum and use fractional coordinates. There are some other specifics, but let's go to practical aspects so that instead of theoretizing, we'll just practice something. So what will be the goal for today? Practical goal. So I'm going to set up a little assignment for myself and invite you to follow, which will be to build a periodic unit cell for one-dimensional titanium dioxide. So we will convert the oligomer to a true infinite polymer. So right now, and because we want to do something simple, we are not going to make it periodicity in 3 dimensions. Instead of doing 3-dimensional crystal, we will do like polymer, like organic polymers, extended periodic only in one direction. This will be just quicker for learning. In opposite directions, we will have just piece of vacuum to isolate. So right now we have terminal agents, these hydroxyl groups, but we will cut them off and make sure that system repeats itself again, and again. So we will identify repeating unit, make sure how much vacuum we need to add, and amount of vacuum is size of this bond, so that atoms do not smash into each other, and process it according to needs of this software. Okay? So please open new directory for this exercise. Name it so that you can always find and identify it, and copy there the output file of your Gaussian calculation of this oligomer. Since I was not doing homework that I assigned to you myself, I respectfully borrowed the output file from one of you, as you can see here. So it was Daniel. This is your file. And in the record, I give you acknowledgement. So after you copy the file to your directory, you may want to convert it from output of Gaussian format to the XYZ format. So we were practicing it at our first couple of weeks. So Babel is conversion program, minus I stands input, minus O stands output, G08 for Gaussian source, XYZ for XYZ output. And now we will do last time when we really practice something with mouse operated. Later on, all of our steps will be command line typing. So please give me signal if you haven't completed conversion to XYZ. So you did, right? Okay, now try to run this software, and you can use something else. I will be showing this one. It is simplest possible visualization software, and it is, we will use it only to measure interatomic distances and remove not needed atoms. So, since we are doing it on a cluster, it will be a little delayed. So do not put much expectations of this software. You will just open and delete a couple of atoms, and then the rest will be done in command line. So I expect that you'll get a picture like this on your screens. Measure typical distances from first to last decade, just to get feeling of success.
So I'm trying to copy it. You just copy it to where.
Let me try something. You Yes.
Good.
You're doing this or something? More fun.
I didn't have the 5 titanium done yet.
But let's.
So I'm
We'll give credit to him. Let's
Just compromise.
see. He gave you permission. But let me help you to steal his file.
Yeah, I just switched over to this directory.
No, let's go to your directory. Proxies out of questions because typically we run such files directly on our local computers, but if you do transmission forward and back, you may lose patience
Okay.
and decide that you do not want to do it anymore. So you should have this picture on your screens. So you may equip yourself with pen and paper or anything how you take records, and do the following. First observe how does it look. So it is titanium O2, titanium O2, but those oxygens go into different planes at the 90 degrees, right? Orthogonal. So probably the unit cell will be 2 titanium and 4 oxygens. So if you cut this size, it will be fine. But sometimes we want to be extra cautious and allow more than 1 unit cell. For which purpose? If you want to catch some additional normal modes, if you let it oscillate, because if you have a smaller unit cell, the electronic properties will be fine. But if you need later to connect them to molecular vibrations, it will be less chances. So if you have unit cell, it will be only one mode. If you have larger cell, it will have more chances to perform collective oscillations. So just as an exercise, we will take 2 unit cells. So 4 titanium and 8 oxygens. So 1 up to here, and second up to there, right? So we'll start with titanium and end with oxygens. And there is a chance to label them with numbers so that we specifically tell which atom we deal with. So we need the size of our simulation cell, and just in case, you can measure a few more interatomic distances and record it. Later, we will use this data in maybe 20 minutes. So measure from first to last titanium, from the oxygens that have the same orientation, and record it. And you do know how to measure distances, right? You can figure it out in any software. So you just click on here, measure, and then you will see the measure interatomic distances, and it will pop up a little menu like this. You click on 2 atoms and click measure, and it will add this distances this way. So from first to last titanium, I've got something like 11.06, and it is about right for the size of the simulation cell. But you better measure yourself. And if Alexa will come, I will be mandated to make a summary of everything we did in 3 minutes. So although this information is shown on the screen, you better write it on a piece of paper, because when we start deleting atoms, this interatomic distance will disappear. Add to measurement. Thing that I'm showing on the screen has a little error that I'm going to quickly fix. So our unit cell will be of this size. So the periodic simulation cell will be 4 titanium and 8 oxygens, right? And the model that we have up front differs from our desired model by extra terminal things. So we have 4 hydroxyls that we want to cut out and 1 titanium that we want to cut out. So it is shown here what is green should be kept and what is red should be removed. Make sense? Do you have an idea how to remove in JMOL? So if you have this general menu, you have this red diagonal cross, like flag of Scotland. I don't know, is there a connection between Scotland and removing atoms, but if you click on it, then it reactivates your marker, your mouse. Everything you click on will be deleted. So you activate this delete mode and start erasing atoms, keeping only 4 titanium and 8 oxygen. And after you are done with erasing, so nothing in red areas. By the way, your interatomic distances will disappear when you start erasing. Therefore, you are making errors. So after you are done with making this model, you may click in the mouse operated system to save, and save it under a different name. I called it sort.xyz because later I need to rearrange them, but you are free to choose any name you like. Erase one more titanium, so that it will be stoichiometric, like ratio of titanium to oxygen. So if you are done with erasing atoms and saving as a new file, and you do not care about show an example to Alyssa, you may close your JMOL.
Like just click X. Oh.
Yeah. Well, you can after you save, after click save.
I was like, I feel like automatically saving's not a thing.
No. If you just close it but do not save, it will not save anything. And if you look into your command line and look inside this file, you are expected to see that first should be number 12, which stands for 4 plus 8, because the computer is so smart. Then some garbage information that we do not need right now. Well, it is not garbage, it is Hartley-Fock total energy, but for other system already. And then the atoms. So you already know that WASP is not user-friendly. It has so many non-friendly aspects. By now you know only 2, that you need to specify atoms and the coordinates are in fractional units. I will disclose them one by one, otherwise you will be very discouraged. So another thing, for WASP people think that they're normal and the rest of the world is crazy. The rest of the world think otherwise. So people who are not in WASP believe that one needs to specify atom before each record. Like oxygen, 3 coordinates, titanium, 3 coordinates. And then you can toss them in any order you like, right? WASP was written in Austria by Germans, and they think that order should exist. So, and you do not need to waste time on giving name of elements if they are repeating. You just need to tell if there are 12 atoms, let's agree that first 8 of them will be all oxygens, last 4 of them will be titanium, and then we remove this column. But in order to practice such ordered style, we need to move this two oxygens higher up, right? Do not do it, do not do it, do not do it. You may record just for your memory, but do not practice it. Because we will be running at least 20 more models in VASP. And if they are more than 100 atoms, you will be very tired to move atoms manually, right? No one is expects you to do so. There is Linux command for sorting files according to alphabetic title of the first column. So let's practice it. And I think my slides are finished at this point. For the rest, I will be on the same page with you, going. Sort to postcard.xyz. Is the font large enough for you to see from each row? Okay, so you do this command of sorting, and this symbol bigger angular bracket shows direction where to forward the output. And now you're looking for this postcard.xyz, and you observe that all records are ordered alphabetically. Numbers, then alphabetically. O, TI, 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 TI. And then this garbage at the bottom. So we need slightly corrected manually. So first, by the international convention for XYZ file, first line is number of atoms, second line is service line. If you don't care what is there, we need to make it empty. So we need to insert empty line. And we may want to remove this last garbage line. So I'm going to do it in the VI or nano editor, whatever I like better. So if I do in VI, then I'm going to second line, and you will not see it, pushing the letter I for insert. See, it shows insert here. And then click enter to add line. Then I'm going to last line and typing escape DD for deleting. And then I'm typing escape column write and quit WQ. I'll go around, and nano editor is a little more user friendly. But you need empty line, and you need to remove last line to the format that when you next time do your more of the postcard file, it has empty line here and nothing at the bottom. Let me check with you. Okay.
Seems still lost it. Is that right? Thing for it to me.
So if I cannot read book, list minus T time, so last open read directly. So and now you slowly come to the idea of the next derivatives.
Yeah, I kind of forgot the name you put the directory as.
But arranging by time you will at least see what was really last. So
Yeah, that.
just expecting very large shift.
Yeah, like keep looks different. Yeah, so yeah. Oh.
But you can do none of in knowledge.
Oh, okay.
So right now it is a normal file. We gave it name postcard.xyz, but it is not postcard for WASP. It is still XYZ file. Let me go to our yes. Very ugly writing. So we will convert into WASP in 2 steps. 10 years ago there were no public converters. Right now they appear, but they're still not very organized, and pieces of software for converting, especially created by chemical chemists, do not include the software because some people hate it. So please do not start hating it before you see outcome. So the tools that I will offer to use are not standard, they're kind of homegrown, but they are really useful and intuitive to use. So the first tool is nominal. It doesn't change anything. It kind of preparatory step. If you do not change orientation of your system in space. Later on, you may want to rotate your model in the following sense. Sometimes you may analyze charge transfer in different kinds of systems, and typically charge transfer has the direction. And if you have slightly different systems, but you want to put them side by side and compare, the following doesn't have scientific sense, but it is very comfortable to agree that if you have one-dimensional charge transfer, it will be along z direction, or x and y. So if your model is donor and acceptor aligned along different axes, you may reorient it. Or by some other reason, you may just rotate. So the little tool that we are going to practice right now is inherited from the need to rotate, But if you want to keep orientation, you just run it and it will save intermediate file. So let me do it quickly. So the rotate XYZ. So I click enter and give 0 arguments. 0, 0, 0. So it means keep the same orientation. If by some reason we need to change, you know that 3-dimensional rotation has 3 arguments, right? And you can rotate, if you want to rotate in X, Y plane, you need to rotate around Z axis. So you can figure it out later if you need. Right now, we don't. So what I do to check sanity, that nothing was corrupt and damaged, after each step, ls minus lt, to see if next files appear. Yes, it shows that last file I saw was postcar.xyz. Here there are 4 new files. I need only the last one. Postcar rotated whatever, XYZ.
ZYX.
ZYX. So I even do not need to look inside. And now there is a special step. So the intermediate file that we have created, it is in so-called Tinker format. It is used for force field molecular dynamics, and we are going to convert it into VASP. So the script, Perl script to convert it is tink number 2 VASP, PL, and then there are several arguments. So do not worry and do not panic. This is probably most challenging and non-usual operation. So we will go slowly through it. So for this Perl script, we need to put in several arguments. Space, then the file postcar underscore rotate, and then whatever is there, z, x, y, x, y, z. Then space, I'm just going to next line, and give the name of the file that we are creating, the output file. It will be postcar uppercase. If you do lowercase, VASP software will not take it. It's just case sensitive. And then there will be space delta x, space delta y, space delta z. So 3 adjustment parameters which artificially add vacuum to your model. If you are chemical chemist and you want to simulate only molecules, if you don't care about periodicity, you just add some relatively large number, like 10 angstrom in each direction, 10, 10, 10. Or if you are greedy and you know that large amount of vacuum takes computational resources, the minimal reasonable amount is 7 angstrom of vacuum. If you do less, it will start hybridizing with neighbor. So you put 7, 7, 7. But then you will not have solids and periodicity. So if you just want to use VASP for chemical models, you do this tink to VASP, the Tinker file after that was obtained after rotation, output file, and then 3 numbers, 777, spaced by space. And you are good to go. Also, if you do like quantum dots, which are not on a substrate, which just standalone quantum dots, just put 777 and you're good to go. But then we do not have full capacity. Right now we need to learn how to model true solids. with true periodicity that will enable us to model polymers, nanorods, nanowires, thin films, and actual crystals. So right now, our nanowire was arranged along X, so we will need to compute and add very specific number. It will be like about 1 angstrom for delta X, and for Y and Z we will put something like 7 angstrom. But the exact numbers is a challenge. So we should stay sober, alert, concentrated to do this operation. It looks quick, but it is, if we fail here, the rest of the computation will be garbage. So it's better to spend a little more time, slowly but surely, but complete it. Okay. So first time I'm doing a fake run. It's not, I can move it this way.
Is that WAT supposed to be in there?
Yes, yes. I think, we were a group of enthusiasts at the University of Washington, and one of us decided to glorify his name, which was Walter, and at the end of the code, he added his name. But it was edited and contributed by many people. It went through. But this version is a little more reliable. So, and in programming, if something is working, do not touch it. So, the code, the input file, output file, and then I am putting no vacuum, 0 vacuum. It is a big shortcoming, a big bad thing. After doing this, it will be very wrong to run this file. So it is intermediate step. I'm intentionally doing an error, and then I'm going to correct it together with you. Why I'm doing this error? So if you have atoms only in this area, the script will automatically remove any vacuum if you do not artificially add, and make minimal possible cubic box that hugs available atoms. So it will shrink size of the box until it meets an atom on the left, right, top, or forward or backward. So it will shrink it in such a way that there will be atom either at left or right. If you have unit cell with only 1 atom, it will be 0 size, infinitely small box. We are going to do the following exercise. We are going to run it and see which size of the box it will create. And then we will compare it with the ideal box that we have computed, that you have found through your measurements from first to last. It will be something like 11 angstrom in your measurements along X direction. So we will run this command and find which size of the box it will create. It will create a box maybe of the 10 angstrom or maybe 9 angstrom, leaving no space for bond to the neighbor. But then we will take our educated knowledge about the actual size of the box and subtract this number. And then we will find amount of adjustment that we need to add. You see the logic? Running it, and it tells So after you run the script, it tells how big the box was according to this principle of minimization. So it was 9.6 along X, 1.9, 1.9 along Y and Z. So right now, I need to go back to my records about desired size of the periodic cell, which was about 11, and subtract 11 minus 9.66, which will be like 1.44 or 34. But I want to be very careful. Right now we're doing everything for exercise and it is not so important, but later when we will do real systems, error in third digit may screw energy by 1 eV or gap by 2 eV. So it is the accuracy at this point gives benefits later. So many people think that wet chemistry needs careful processing and computational chemistry is just laying on a sofa and in a relaxed way just clicking on mouse. No dirty work. There is a dirty work. One needs to be careful and alert with doing these things. And same as if you do not wash the test tube before experiment, you'll get garbage in your measurements. Same here. So let me go to the measurements of the So the size of the cell should be 11.062, right? I should record it somewhere. BC 11.062, right? BC is like board calculator, not British Columbia. BC minus this much. So 1.4015. So it is our adjustment. And by your chemical intuition, you know that it is somewhat in the range of chemical bond. Well, it is at angle. The actual bond between titanium and oxygen is bigger, so it is about some angle. So it is bond length times cosine, whatever, 45 degrees will be this. But range, order of magnitude, is between 1 and 2 angstrom is reasonable, right? So we will need this number. So please do these calculations based on your data, which can be a little bit different. And make some records for yourself. If you do not count on your memory, it's better to record it right now. I do not have the sayings anywhere in slides, so it is your intuition how to explain this procedure. I'll try to put a slide with it, but it will be not very informative. Hi, Lisa.
Hello.
How are you?
I'm good. How are you?
Very good. Very good.
Small class.
So, what I'm doing right now, I'm removing these 3 zeros and putting the number that we just computed as a first of them. So I'm literally copying this adjustment parameter And for the remaining two, I'm putting 10 and 10, or 7 and 7 for vacuum. So we haven't checked what we've got, but I expect that by completing this operation, we do have healthy input file that would work for WASP software. More. And as we do always, ls minus lt to see what appeared. So we do see that there appeared a postcard file, right? And we may look inside and inspect how it looks like. Postcard file, this is 2018 class. 2018 class is a postcard file. I have introduced you to each other. So you see numbers, right? And you observe that in this main, also I will be summarizing everything we did in a couple of minutes. I just want to complete the thought.
Okay.
So you see numbers, and all of them are between 0 and 1, right? You do have two numbers that you recognize, 8 and 4. And you have names of elements, O and Ti. So O8, Ti4. It's like chemical composition, which means that the first 8 records stand for positions of oxygen atoms in
You are
fractional
the only
groups.
participant in the conference.
Okay, I don't mind. So where is the size of the cell, of the simulation cell? This box,
Avaya.
this box of 3 by 3, 9
A
numbers.
moderator is already present. You will now be placed into the conference.
Thank you so much. So along X, the box is 11.061, along Y it is 11, along Z it is 11. So it is a cube of about 11 by 11 by 11. So if you want to know the coordinates of the first oxygen, you multiply 0.31 by 11.06, 0.56 by 11, and 0.58 by 11. And we will get something like 666 angstrom, somewhere in the middle of the cell. Do not hate me, do not hate WASP. I understand that it is not user-friendly, but later there are a lot of benefits of these practical steps. So, if you have done it, please try to look through I'm going to send everyone a file so that while I will be repeating and summarizing, you do not feel bored if you already know everything about the steps. I'll send you a file with kind of step-by-step instructions for further things.
Okay.
You are the only participant in the conference.
Avaya. Please enter your collaboration code followed by the pound key.
Sure.
The collaboration code entered is invalid. Please re-enter your collaboration code followed by the pound key. The collaboration code entered is invalid. Please re-enter your collaboration code followed by the pound key.
Okay, so you have more than needed information. If
There
you
is no operator available. Please contact your local administrator.
I'll just mute that because the call is going on.
Huh?
I don't know why it's saying that, so you can just decrease the volume because the call is going on just fine.
Okay.